Welcome back to another video on object-oriented programming using C Sharp, and the topic that we are discussing today is abstraction. Have you ever wondered how to make complex systems simple to use, or how software engineers hide unnecessary details from the end user? That is abstraction in action. To begin with, let's see a high-level map of what we will explore under the topic of abstraction. Let's break it down. First, we will talk about how abstraction helps in hiding implementation details. This is what allows you to interact with an object or a system without having to worry about its inner complexities. Next, we will discuss the difference between abstract class and interfaces. These are two powerful tools in C Sharp, and understanding when to use what is crucial for designing robust and maintainable code. And finally, we will touch upon interface segregation principle, which is one of the solid principles in object-oriented programming. We will also discuss this in a separate video, but we will have a glimpse of interface segregation principle. This principle ensures that your interface remain clean, focused, and easy to implement, helping you write better code in a long run. So by end of this video, you will not only know what abstraction is, you will also understand how to leverage it to build scalable, flexible applications in C Sharp. Let's get started. Let's start by understanding what abstraction really means in the world of programming. Abstraction is all about hiding the complex internal details and showing only the essential features of an object or a system. This means, as programmers, we don't have to worry about every tiny inner workings behind the scenes. We can focus on the parts that really matters to us. A great analogy for this is an ATM machine. When you use an ATM machine, you're presented with a simple, well-defined user interface using which you can withdraw cash, you can check your balance, or even deposit funds. But what you don't see are the complex operation that happens behind the scenes, like authentication, transaction processing, communicating with the bank server, security checks, or even how the cash dispenser works internally. All of that internal complexity is hidden from you. All you care is pressing few buttons and getting the job done. This is exactly what abstraction is in programming. It helps reduce complexity and allows developers to focus on interactions at higher level without getting bogged down by unnecessary details. So whenever you interact with a system that seems simple on the surface, but you know there's a lot happening in the background, that is abstraction in action. Now let's get started with the first topic, that is hiding implementation details. Let's look at this with an example that will help us understand better. Let's look at hiding implementation with an example that all of us can relate to: driving a car. On the left side of the slide, you see inside of a car from a driver's perspective. Everything looks familiar: the steering wheel, the dashboard, gear lever, and a beautiful open road ahead. But notice what you don't see. You can't see the engine, you can't see the gears turning, or the electronic control system managing every movement. All the internal complexity is hidden from you, and we call that abstraction, just because it hides all the complexity and exposes only a well defined interface what the user needs to interact with the system. Now, as a driver, you just need controls provided to you: the steering wheel to turn, the pedals to accelerate or brake, or maybe shift gears if you're driving manual. Now, on the right side, we have the same view, but this time it's like we have activated a X-ray vision. You can see the engine, transmission system, moving mechanical parts, and electronics that actually make the car work. This is called as concrete implementation, the real messy, complex world under the hood. And this right here is the essence of abstraction in programming. Abstraction is about exposing only what is necessary. the controls the user needs while hiding the underlying complexity. Just like car's driver only needs the interface, steering wheel, pedals, dashboard, the programmer or the user of the class only needs to know how to interact with it, not how it's built inside. On the other hand, the concrete implementation, all those hidden systems and mechanisms, that's what makes everything actually work. But it's not of driver's concern. So when you design software, think about what user really needs to interact with and what details can be kept hidden. Just like how car designers protect us from all these under the hood complexity. That's abstraction in action, making things simple for the user and handling complexity behind the scenes. Now let's look at this with a code example to understand it better. In this example, we define an interface IATM that has three methods: insert card, enter PIN, and withdraw cash. The actual ATM machine, the real object, or the class that implements this interface, can have complex logic inside those methods. It can do all sort of complex things like validating the card, encrypting the PIN, talking to remote server, or handling cache securely in its implementation of insert card, enter PIN, and withdraw cache. But for the person who's using the ATM, like the place where this object is being consumed, they don't see any of that complexity. They just create an object of ATM of the reference type IATM, and they just call the methods and get the result they want. That is the power of abstraction, hiding the implementation details and exposing only what is needed. So in this case, to use the system, user needs to know this well-defined interfaces: insert card, enter PIN, and withdraw cash, using which they can get the result they want. Now let us start with understanding what is an abstract class. It is like a blueprint for other classes. You cannot create an object of an abstract class directly. Instead, it is meant to be inherited by other classes, and then they fill in the missing details. Abstract class is a great pick if we have to design a base class wherein we have some common code that has to be implemented at the base class level, because it can have methods with and without code. That is the main difference between an abstract class and an interface. An abstract class can have methods with code and some without, but interface can have only abstract methods, the methods with just declaration and no definition. Now let's look at it with a code example. Let's imagine you're building a payment system for an online store. You want to support different payment methods like credit card and PayPal. The overall payment process always follows the same basic steps. Step 1, authenticate the payment method. Step 2, process the payment. And 3, print the receipt. But here's the catch: the way you authenticate and process a payment is different for each method. This is where an abstract class is a perfect tool in C Sharp. We have created an abstract class called payment. It defines a template method make payment that calls all the required steps in order, defining the order in which it has to be executed, but leaves the details of authenticate and process payment as abstract methods, which means that each derived class has to implement them in its own way. For example, credit card payment authenticates and processes a card, while PayPal payment authenticates and processes a PayPal account. No matter what payment method you choose, you always get a receipt, because that logic is already provided in the abstract base class. Since this is a common logic, it has been implemented in the abstract base class. So, abstract base class provides the blueprint. It defines what must happen and in what order, but each derived class can fill in the details based on its specific requirements. This approach makes your code much easier to extend. If you want to add a new payment method, just create a new class that inherits from payment and implement the abstract steps. That's the power of abstract classes. They let you share common logic, enforce structure, and allows flexibility for different implementation. Now let us look at interfaces. It is a contract that defines a set of methods, properties, and events without any implementation. We will find only declaration with no implementation, unlike abstract classes. It specifies what a class must do, but not how it does it. Classes that implement the interface must provide concrete implementation to all of its members to abide with the contract. Let's look at this with an example to understand it better. Let's say you're building a smart home system and you want to control devices like lights, fans, and heater, but you don't want your controller to take care of details of each device. You just want a simple way to turn any device on and off. This is a perfect situation for using an interface. You can define an interface called iSmartDevice. This interface specifies two methods, turn on and turn off. So we have our contract ready, that is iSmartDevice. Now each device, light, fan, and heater, implement this interface, providing its own way to switch on or switch off. The key thing here is your smart home controller doesn't care if it is talking to light, fan, or heater. It just calls turn on and turn off on any device that implements iSmart device. This is the core idea of interfaces. They allow you to define what actions are possible without specifying how those actions are performed. It's like having a universal remote that can turn on or turn off your devices in your house as long as they abide by the contract. That's how interface provides flexibility and consistency. We see here it depends on iSmart device and not on the object of any concrete implementation. That is what we call as flexibility. So tomorrow if we have a new implementation, we can pass that object still in until it satisfies the contract of iSmart device. There is where the flexibility comes in. We have completed looking at hiding implementation details and abstract classes versus interfaces. Now let's jump into interface segregation principle. The interface segregation principle is the I in solid principles. I wanted to keep this really simple because we will be having a whole dedicated series of videos on solid principles. To keep it simple, it states clients should not be forced to depend on interfaces they do not use. It means don't make a class implement methods that it doesn't need. Instead, break large, fat interfaces into small, granular, more specific ones so that the class don't have to implement what they don't need. Let's look at this and understand with an example. So now what we have in front of us is an example of an ISP violation, a code that violates interface segregation principle. Imagine you have different types of documents in a document management system. Some documents can be printed, some can be scanned, and some can be faxed. If you create a big interface with all three methods, print, scan, and fax, classes like photocopier, printer, or an old fax machine will be forced to implement unnecessary methods. Now, let us fix this by resolving this violation of ISP in the next example. In this example, we have divided the big fat interface into smaller and focused ones. We have iPrinter for printing, iScanner for scanning, and iFax for faxing. Now, Printer class only implements iPrinter. A photocopier can implement both iPrinter and iScanner. An old fax machine can just implement iFax. This way, each class only signs up for a feature that it actually supports, making code cleaner, safer, and much easier to maintain. So the next time you design an interface, ask yourself, is this interface doing too much or doing more than what it should be doing? Can I break it down into smaller and more focused interfaces? That's how you apply ISP in real world C Sharp applications. Thank you for watching our video. Do subscribe our channel for more such videos, and thank you for your support.